So in this video, we're going to talk about simple random sampling and how to use a random digits table to do that, to take a simple random sample. So kind of taking a step back, we've talked about random sampling as being a good way to sample. I should have some type of randomness involved if I want to take a good sample. And in this class, we're going to talk about specifically 3 different types of random sampling. Simple random sampling being one, and then stratified, and then cluster. So this is the one we're talking about today. Oftentimes, when we introduce this first, people think this is the only way to take a random sample and the best way. That's not necessarily the case. It's just the simplest way. So there are really 2 things that make a simple random sample, and one of them really distinguishes it from the 2 other types of random samples that we're going to look at. So I'm going to tell you what those are, and then once we start to look at these other 2 types, stratified and cluster, we'll come back to that and see how those are a little bit different. But the first is that in a simple random sample, every individual in the population has an equal chance of being chosen for the sample. Makes sense. True about a lot of types of random samples, also true about simple random sampling. The second is a little bit more confusing and a little bit more specific, and the one that makes simple random samples different from the other types of random samples. It is that every possible group of the size of our sample has an equal chance of being chosen as the sample. So a little bit wordy, but basically what we're saying is if we look down here, our samples are going to be of size 3. We're sampling stores from the mall to ask them about their holiday hours. So there are many possible groups from these 21 stores that are of size 3, of the size of our sample. And for a simple random sample, every group of size 3 that exists should have an equal chance of being the sample, which is the group of size 3. It's kind of hard to see when that wouldn't happen, but when we look at our other 2 types of sampling, stratified and cluster, I'll show you how that is not the case. But in this case, basically what we're saying is that if these first 3 stores were chosen, that's a possibility, and it should be the same possibility as these last 3 stores being chosen, or the last 2 and the first one as a group, etc. So we've looked at before, and we'll continue to look at taking random samples with a calculator. So if I wanted to take 3 random stores from this group of size 21, I can do that with the calculator. The calculator will generate random digits for me. And really what I want, if there's 21 stores, I want to generate random numbers between 1 and 21. So I can tell the calculator, give me random integers, so that they're not decimals, between 1 and 21, and it'll spit out random numbers between 1 and 21. The only thing is the calculator doesn't know not to repeat those numbers, so I'd have to be sure to skip over repeats when I get them. Otherwise, I can find my 3 stores that way. The thing is that sometimes, especially on tests, you're going to be asked to do this with what's called a random digits table and not with your calculator. The biggest reason is it's really easy to check if you can do it and you're doing it correctly. A calculator, it's really easy to pretend you know what you're doing and not even know the calculator command and still come up with 3 random numbers that actually were just generated by you in your head. So the table is a good way of checking that you know how to do that. So you kind of have to know how to use the table for both my tests and for the AP test. So I'm going to show you how to do that right now. So here's our random digits table. It is organized by line, so it starts at 101. I'm not sure why it just doesn't start at 1, but it doesn't. It starts at 101. This is the one that's in the back of your book. There are different random digits table that exists, but you'll find this one a lot of places. And after these numbers, which is just the reference number of the line, we start listing random digits. This gap right here means nothing besides allowing your eye to kind of have a break so it's easier to read. So the random digits go 1, 9, 2, 2, 3, 9, 5, 0, 3, 4, etc. And when I get to the end, 5, 3, I keep going over to here. So I can just wrap around to the next line, just like how I read 7, 3, 6, 7, 6, etc. And here's how I would use it. Let's say there were 9 stores that I was picking from, and I labeled the stores 1 through 9. What I want to do is choose a line to start on. That really doesn't matter. So I'm going to choose line 115. Okay, so I'm going to choose line 115 to start on. And then what I do is, if my digits are my stores are labeled 1 to 9, I'm going to pick 3 of them. I'm taking 1 digit at a time. So for example, my first digit that I come to is 6. And then 1. So I have the stores that correspond to what I labeled 6 and what I labeled 1. And then I'm going to keep going, and I get 0. Here we've run into a problem because my stores are labeled 1 through 9. So there is where I'd have to ignore some numbers that I get outside my range, which doesn't happen in the calculator. But this is an important piece, because what's going to happen is a lot of times you're going to be asked to describe your process before you even do it. And those kind of things that can come up, repeats, numbers outside your range, etc., etc. I need to make sure I mention beforehand and say, when these numbers come up, I'm going to skip them. And I'll go through an example to show you that. But that can happen. But then I would just keep going. It's okay. I don't need 0. So I'd cross that out. And then I have 4. And that's the last store I need. So I have finished my sample. You can see if I wanted 4 stores and I keep going, I would get 1 again. And that's, again, where I would have to skip repeats and keep going on to the next one, which would be 7. Okay, so that was if I had 9 stores. Let's kind of think about what would happen if I had 10 stores. You could say label the stores 1 through 10, but we're going to run into a big issue there. Because if I label the stores 1 through 10 and I choose them like I did here, 1 digit at a time, store 10 can't ever be chosen. I'll never get 10 when I'm taking 1 digit at a time. But there is a fix here for 1 through 10, and that is, oh hey, that's 0 that I wasn't using before that I wanted to leave out. One of my stores can be labeled 0, right? 0 is a digit that in our calculator we don't really bother with because it kind of isn't as intuitive, but on a random digits table we can totally use it. So for 10 stores, I may label them 0 through 9. Right, and same process, I'd go through picking, and when I got 0, so say like I got this 0, I wouldn't leave it out. The bigger problem comes when I have maybe 11 stores, right? I don't have 11 digits that exist, so I can't label the stores with 1 digit at a time. We're going to start taking 2 digits at a time. So I'm going to do this with our 21 stores and show you the things that can happen. And then what we'll do is we will step back and write out the directions as if we were writing it before we took the actual sample from the random digits table. Okay, so I made this one a little bit bigger so we could see what's going on here a little bit clearer. But if you remember, we had 21 stores. So we would have labeled our stores numbers from 1 to 21. The problem is I don't want to say 1 to 21 because I'm never going to get 1 digit. So with the calculator, we can do that because the calculator does give us, it understands that 1 is an option, as is 21. When I take 2 digits at a time on this table, which I'm going to have to do when my stores go up to 2 digits, 1 doesn't exist. But 0, 1 is going to be one of my options, and 0, 1 is just as likely as 21. Right? So I would probably label my stores 0, 1 through 21. And then all 21 of those stores has an equal chance of occurring in my random digits table. I could also have done 0, 0 to 20. That leaves me 21 digits. in the same way. I could have done 21 to 31, just kind of silly. I kind of tend to stick with something like this that makes more sense to us. So we're looking for digits, or sorry, 2-digit numbers between 0, 1, and 21. Others we'll leave out, and we're also going to leave out repeats. Once I get 3, I've found my 3 stores that I want. So we're told to start on line 101 for this one, so I'm going to go ahead and do that. And here's what happens, right? My first is 19. That is in my range, so I'm going to circle it. There's my first store, right? 22, not in my range. Not going to use that one. 39, not in my range. Not going to use that one. 50, no. 34, no. 05, yeah, I like it, right? That's the 5th store, so I'm taking it. 75, no. 62, nope. 87, nope. Up 13. So I found my 3rd store. I have stores 19, 5, or 05 in this case, and 13. And those will be my stores that I go and ask about their hours. So here's my list of stores, and we said 19 was the first run, right? So Star Jewelers would be one of the stores that we survey. And then we got 5, I think, next, right? So Carter's for Kids. And then 13, which would be this one. Oops. This one right here. So those are our 3 stores, and then we go and survey those 3 stores. So here's what I would kind of say if I were describing this on a test and had to include all those specific things that I was going to make sure that I did. So here's how specific you need to be. I would do this in bullet points, just makes it much, much easier. But I start by labeling my stores, right? And in this case, it is 0, 1 through 21. And like I said, when I'm using a random digits table, not when I'm using a calculator or any type of technology, but a random digits table, that 0 is important. So I'm going to label them 0, 1 through 21. Then what I'm going to do is take 2 digits at a time. Right, before I only needed 1, but I have to say that. Whichever I'm going to do, I need to say that. So 2 digits at a time. I should probably say starting on line 101. When I take those 2 digits, I'm going to ignore 0, 0, right? That could happen. And 22 to 99. So all the 2-digit numbers that I don't want, I need to say I'm going to leave those out. And I'm going to skip repeats if they occur. Right? I don't want the same store twice here. Even if this isn't going to happen, I need to say that this is what I'm going to do. So I'm going to ignore the ones outside of my range. I'm going to skip repeats. And then I'm taking numbers, right? But if I stop here, whoever's reading this is thinking, wow, you're just going to take numbers forever and ever until you've exhausted the numbers 0, 1 to 21. So I need to say when I'm going to stop. That's something that a lot of people often forget. So I'm going to put it in red. And I'll say once I have 3 unique numbers, I'll stop. And then I will survey stores that correspond to those numbers, because I'm not really done once I have my numbers. One thing that I often see is people will say something like, take 3 random stores, right? But here I'm not taking 3 random stores. I'm finding 3 random numbers, and then they correspond to those stores. So just kind of being specific about what are you actually doing, thinking before you start writing, what is my process going to be to get me here? And if you do that and you're specific, you'll get all those steps. But you do need all of these steps to get full credit on one of these questions. So that is how I use a random digits table. And you'll see, you can kind of see if I were up to 3-digit numbers, it gets pretty brutal. I don't want to use a random digits table for when I'm picking 3-digit numbers at a time. So that's what's nice about having the calculator and having technology. This is just something, first of all, just show you understand how random digits work, and something that you'll sometimes use on one of my tests or on the AP test. And that's it.